So what we're looking at are the valence electron configurations for an element, and the question is how many bonds can each atom make without hybridization? So we don't need to know what hybridization is to do this problem. Let's take the first one. The first one is silicon right here, and let's find that on the periodic table and take a look at where silicon is. So silicon is over here in the right, and I'm circling it in blue. And if you notice, it's in this column. And if you remember your orbitals, we have over here on the left of the periodic table, these first two rows is S, and then the block all the way on the right side, finishing out the group A, this is P. If you remember on in your orbitals, S only has two rows or two columns in it. So divide that by 2, so S is only going to have one orbital. So that's the orbital S. And then P has 1, 2, 3, 4, 5, 6 columns in P. So divide that by 2. So P is going to have 3 orbitals. So these are the P's. Now silicon starts in row 3. Here's row 3 right here. And so you have these two S's that you have to go through. And when we're doing these, we only use the row that the element is in. Don't worry about row 1 and 2. We're only using row 3 because that's the row silicon's in. So there's two elements in S in that column. And so for S up here, we're going to write an up arrow for the first one and a down arrow for the second one. Now for P, we follow this all the way over to the P block. And silicon is two elements into the P block. There's aluminum and then there's silicon. So that's 2. So up here on in the P orbitals, you only put one arrow in each orbital at a time, and then you go back and put in the second orbital. But we don't have enough electrons to put in all the orbitals because silicon is only 2 elements in. So we're only going to have 2 arrows, one in each of the first two orbitals of P. So if we go back to our problem here, we have the S, and then we have the P. And P has 3. I like to think of them as roller coaster cars. You can only fit 2 people in a roller coaster car at a time. So each of these little lines is one orbital where you can fit 2 electrons in at a time. But you can only fill them up one each, and then you have to go back and fill up the second electrons. So for S, once again, we have 2 S's. So that means we're going to go one arrow pointing up, and the second one you point down. Now for silicon, the P value is 2. So that means we're going to have 2 arrows, and we can only fill up one arrow in each orbital at a time. So 1, and then you move on to the next one, 2. So that is what silicon looks like, 3s2, 3p2. So if we go back and take a look at this S, 3s silicon is 3s2, so we're going to have 2 electrons that make up this pair. So we're going to have one pair of electrons. And then we're going to look up at this P, and we have two lonely arrows in separate orbitals for p. So these are unpaired electrons. So these are two unpaired electrons. So the pair is complete. It's a complete pair, so it's completely fine by itself for the S. But the two unpaired electrons for the P means that those two unpaired electrons, each one of those, can form a bond with another atom. So there are two unpaired electrons equals two bonds that silicon can form because it has two unpaired electrons that are free to bond with other electrons from other elements. Now let's look at carbon. Carbon is in row 2, so we're only going to worry about row 2. So there's one S, and there are 3 P's, as usual. And carbon has 2 S's right here. So the S's is going to go 1 electron, 2 electrons. Now the P's, carbon has 2 P's in that row 2, so it's going to go 1 electron, 2 electrons. So once again, the answer is the same for carbon that it is for silicon. There's one pair and there's 2 unpaired. So that's going to equal, or that's going to be able to make 2 bonds, because those unpaired electrons are free to pair with other electrons from other atoms. Now let's take a look at the periodic table for a minute. If you notice, silicon and carbon both have the same electronic configuration, just from different rows. They both have one pair, and so we would call that one lone pair. And they both have 2 unpaired electrons, meaning they can form 2 bonds. Now look at this. See, the first one we had was silicon, and silicon is right here. And the next one we did was carbon, and carbon is up here. So as you can see, anything in this column right here, anything in this column is going to have an S value of 2 on its own row, and a p-value of 2 on its own row. So that means anything in this column is going to have one lone pair of electrons and 2 unpaired electrons, meaning they can form 2 bonds. Now let's go back to our last problem. So sulfur. Now, where is sulfur on the periodic table? Sulfur is going to be right here in group 6A. So that's going to have 2 S's like normal, and then you're going to come over here, and then it's going to have 3 P's, 1, 2, or 4 P's, sorry, 3, and then 4. So it's going to be it's going to have 4 electrons in its p value. So here's sulfur, and see that it has 3s2. So the S, it's going to have 1 S, and of course, once again, it's going to have 3 P's, because any row in the P block is going to have 3 P's. That doesn't change. So for the S has 2 electrons, so we're going to go 1, 2, and in this case, the P of sulfur, it's going to have 4 electrons in that row in the P block for sulfur. So we're going to go 1, 2, 3, And then for the fourth one, we go back to the very first orbital and we put the fourth electron as the down arrow on that line. So now sulfur, if you look, sulfur has this lone pair from the s block, and then it also has this lone pair from the first p orbital on the p block. So these are both lone pairs. And how many lone pairs are there? There's two, because there's two sets. There's two pairs. So there's one pair and there's two pairs. So two lone pairs. And then P has left over these lonely guys, these unpaired electrons, and that's two unpaired electrons, which means it can form two bonds. And that's how you can determine how many bonds and how many lone pairs for each atom if they make them without hybridization.